Okay, so in this video, we'll be now revising a question from a 2024 past paper written by the GCE's mathematics. Specifically, we'll be looking at question 3 from section B. All right, so without further ado, the question reads, in the following diagram, OA is equal to vector A, OB is equal to vector B, and AX to AB is equal to 2 to 3. Okay. And we have that diagram there. Then the first question reads, express in terms of vector A and of vector B. The first question, that is the root AB. We find the root AB. So this is very, very simple. And vectors are very, very important to understand because you'll find this in paper 1 and paper 2. All right. So let's find out how we're supposed to carefully analyze and correctly answer this question. Okay, so the root AB, let's go to where AB is. So they're asking us to find the root which will move us from A going to B. This is very simple. This is very, very simple. Okay, so where we're supposed to pass, there should be a root, and a root is denominated by an arrowhead. So here we have a root, this one. Even here we have a root, this one. There are no roots this side because we don't have arrowheads this side. That's one thing that you need to take note. So for me to move from A to B, I'll just say I'll first move from A to O, then from O to B. As simple as that, okay? So let's start. So AB should be equal to, we'll first start from A, then go to O. Then plus, so from O, we'll now go to B. As simple as that. Don't forget to show the direction of your root. And one common thing that you need to understand here, or the most essential thing, when you're writing such a formula, these two letters will be common. Then these two letters will represent what is here, because this is your starting point and this is your destination. Okay? So, after that, we can now just say AB should be equal to, what is AO? Let's go to the diagram. So AO, here this root is OA, looking at the arrow. Okay, the arrow is pointing this side, so this root is OA, but us what we want is AO. So it's like we're opposing the direction. So once you oppose the direction, it becomes a negative. So we say that to be negative vector A. Okay, why I'm putting a negative is because I'm opposing this direction. Okay, then OB, what is OB? OB, we are not opposing this direction, so it still becomes a positive. So positive vector B. And finally, we can just say therefore AB now. AB is equal to, why am I trying to proceed to the next stage? Because I've seen that this equation is starting with a negative, and according to the laws of mathematics, an equation should not start with a negative. So I'll just interchange these two. This positive comes inside, this negative goes the other way. I'm not crossing the equal sign, so don't change the signs there. We're not crossing the equal sign. Okay, so we are just going to say vector B positive, then negative A. Okay, as simple as that. So this is our AB, as simple as that, and we have our 1 mark. We proceed to the next one. They're saying XB. So for us to move from X going to B, there's something that we need to understand. You can see that I've put some numbers on the diagram there. What are those numbers doing there? Okay, so what it means, if we go back to the question, okay, if we go back to the question, they're saying AX to AB is equal to 2 to 3. So they've given us some ratios here. So they're saying AX, so which means AX, the ratio for AX is what? 2. Then the ratio for AB is what? 3. Okay, so now look at this. It's very simple. So from AX x, they're saying it's a what? A 2. Now, where did I get this one from? This one, they're saying AB, the whole root. Now, the whole root is 3. That's AB. So, if from A to X, there's a 2, and the whole thing is 3, we just say the whole thing, which is 3 minus 2, and we have our 1 here. Okay? Because in this concept, we're now using ratios. Okay? So, we can now come here and say xb, we're going to use ratios. So xb should be equal to, what is the ratio for xb? The ratio for xb is what? 1. Okay, I've explained where I've got this one from. So xb, that is 1. Then what is the total ratio? The total ratio will be 1 plus 2, which is the same AB, which is just what? 3. Okay, so you say the actual ratio you're finding, okay, the root you're finding, its ratio divided by the total ratio. Okay, the total ratio of the whole root. Mind you, xb is just part of AB. Okay, xb is part of AB. Okay, now we're going to now say, so 1 over 3 multiplied by the whole root. What is the whole root? Or the root where xb is part of. The root where xb is part of is AB. So we say multiplied by AB. This is a root. Okay, so we proceed and say xb now. Xb will be equal to 1 divided by 3. Open brackets. What is AB? AB we found in the previous question, which is positive vector B, then negative vector A. Okay, so the secret about vectors, immediately you get the first question wrong, everything becomes wrong because it's a chain. Okay, all right, so we can proceed now and get rid of the brackets here. So we say xb is equal to 1 by vector b, which is still vector b, divided by this 3, which is there, and 1 by negative vector a, which is still negative vector a, over 3. As simple as this. This is our final answer. There's nothing that we can do here. So someone will say, no, we need to find the common denominator. Here we cannot find the common denominator because the numerators are unlike terms. So we cannot find the common denominator. So we also have another mark here. All right. Let's now go to C. What is C saying? So C is saying we find XO. We find XO. So we're going to say XO. XO will be equal to what? Let's go to our diagram here. So from X to O, we can say we move from X to B. Why are we passing here when there is no root? We know this root. We've already found it in the previous question. Okay, so we can use it. So we're going to say for us to move from X to O, we can say from X to B, then from B to O. As simple as that. Let's write our formula. Okay, so XO be equal to XB. XB plus BO. Always indicate the direction of your root. Always indicate the direction of your root. All right, so we can now say XO. XO is equal to, what is XB? XB is here, the one which we found in the previous question. So XB is positive vector B divided by 3, negative vector A divided by 3. This is XB. Then plus what is BO? You got your diagram. BO, we are opposing this direction, so it becomes a negative. Take note, we are opposing this direction, so it becomes a negative. So BO we can say negative vector B. Take note. All right, so here we have something like this. So XO would be equal to positive vector B over 3, negative vector A over 3. Then positive times a negative, it becomes a negative. So we have negative vector b. If you want, you can balance here. You could just put a 1 to also make it a fraction. All right, let's proceed. And now we can collect the like terms. You know that this vector here is a like term with this one. Okay, so we can just say XO will be equal to, you can start with the one which is in positive, you say vector b over 3, then get this one. Don't change the signs because nothing is crossing the equal sign here, please. So negative vector b over 1, then we write this one as the last part. So negative vector a over 3. All right, we continue and say XO is equal to, here we can find the common denominator. Okay, here we can find the common denominator because the numerators are like terms. So we can say, what is the common denominator here? That is 3. So 3 into 3, that is 1. 1 by vector b, which is still vector b. Then we say negative 1 into 3, which is 3. 3 by vector b, which is 3 vector b. 3 vector b. All right, then we say negative vector a over 3. All right, we proceed. So XO now, XO will be equal to, so here these signs are different, so we subtract and maintain a sign from the bigger number. So we have negative 2 vector b over 3. Okay, take note, negative 2 vector b over 3 minus vector a over 3. Okay, here we are done. Okay, again here we cannot find the common denominator because the numerators are unlike terms, and we cannot say we interchange to start with a positive because there's no positive. This is negative 2 vector b and this is negative vector a, so they're all negative, so you just leave them like that. So that is our XO. Okay, let's proceed to the last question now. So the last question reads, and this is my favorite question because it proves everything. So even here, take note, we also have a mark. Okay, now that's saying, given also that OY is equal to 3OX, show that BY is equal to vector A plus vector B. So they've given us the answer. They want us to prove this answer that yes, by is equal to vector A plus vector B. We prove the answer. Okay, so once we prove this answer, we'll know that everything that we've done is correct. That is why I mostly love this question where we're asked to prove. Because once there's anything wrong from our previous answers, then we cannot prove this. Okay, so let's proceed. So we can now go to numero 2. So this is numero 2 here. Okay, so we just get the same by. So we just need to find the same by and see that if it will give us positive vector A and positive vector B. Okay, so by, let's find by. So if we go back to our diagram, where is B? B is here. So by. For me to move from B to Y, I can just say I'll first move from B to O. There's a root here, from B to O. Then from O to Y. Why am I using this root? Because there's no root here, but I can find that root because they've given me the formula in the question. They've said OY is equal to 3OX. Take note of that. Okay, so let's write the formula first. So BY will be equal to BO plus OY. Okay, simple. Now, let's proceed. So BY is equal to, what is BO? BO. So BO, we are opposing this direction. So it becomes a negative. So that will be negative vector B plus, what is OY? Here we don't have OY, so we need to find OY. Okay, separately, let me show you how we're supposed to find OY so that you don't get confused. Mind you, they're saying OY is equal to 3OX. This is very important. So let's find OY somewhere here. Okay, so OY has been said that it should be equal to 3, then OX. 3 OX. All right, so OY should be equal to 3. What is OX? Let's go back to our previous answers. OX. So I have this one here. Here, C. So this one is the opposite of OX because it's XO. So if I change this direction, it becomes OX. Take note, this is very important and tricky sometimes. Okay, so OX is the opposite of XO. Okay, so here, if I want to find OX so that I have OY, I'll say OX is the opposite, that is a negative, okay? The opposite of what? XO. OX is the opposite of XO, which means we've interchanged this direction, okay? So OX is equal to the opposite of XO. What is XO? We found XO here in question C. XO, okay? So we said that XO was negative 2 vector B over 3. Then negative vector A over 3. This was our XO here. Okay, that was our XO. But we want OX. So OX now, which is the opposite, will be equal to, so we say negative by negative, which is a positive. So positive 2 vector B over 3. Negative by negative, which is positive vector A over 3. So this is OX, which is the opposite of XO. Okay, OX is the opposite of XO. Okay, so we come back to OY. Our interest is knowing OY. So OY, so we say 3, then what is OX? OX we've found here, which is 2 vector B over 3, then positive vector A over 3. Okay, so we can now simplify here. Okay, we can now simplify here by saying OY is equal to, so take note here, this is very, very interesting. Okay, this is very interesting here when we have this, which means this whole thing OX is divided by 3. Take note, this is one and the same thing. This is the most common mistakes that pupils make. So 3 open brackets, this is the same thing I'm writing. So 2 vector B plus vector A, everything over 3. It's the same as this. Okay, this and this are just one and the same. You are saying over 3, here over 3. So the common thing is 3. Okay, so here we can simplify and say this 3 and that 3 can go. Okay, so that OY is equal to 2 vector B plus vector A. So this is our OY. This is our OY. We go back to our question. So BY we said is equal to negative vector B plus, what is our OY? OY, the one we're from finding, which is positive 2 vector B plus vector A. So that BY is now equal to, so we can collect the like terms. So A is just alone, so you can say vector A. Then we group these together. So you can either start with this one or this one. It's one and the same. So I prefer starting with a positive. So positive 2 vector B, then negative vector B. Here I've only collected the like terms. So don't change the signs because there is nothing that is crossing the equal sign here. Okay, so BY is equal to vector A. These are like terms. So you can say 2 vector B minus vector B. So which means we're going to have, or here you can just use that concept where we say these signs are different. So when the signs are different, you subtract and maintain the sign from the bigger number. So that is positive vector B. So if you look at this answer and you look at the answer that they gave us, they're just one and the same. So you can say hence shown. Hence shown. Okay? Hence shown that by is equal to vector A positive vector B. As simple as that. Okay? So which means you've proved that by is equal to vector A plus vector B. Okay, so if these other answers were wrong, you cannot have this answer. Okay, so for this one we have our 2 marks. So here we had 1 mark, 1 mark, 1 mark plus our 2 marks here. So we have a total of 5 free marks. As simple as this. I call them free marks because they are very, very simple.